This is CBSE AIPMT 2015 question from thermodynamics. The question is this: 1 mole of an ideal diatomic gas. So be careful in understanding that it's a diatomic gas where its gamma is 5/3. So first thing that you need to know is for a diatomic gas, gamma is 5/3. What is that gamma actually? The ratio of specific heats of gas at constant pressure to constant volume, Cp. You can write here the values of CPs and CVs. Otherwise, we'll say in another way like degree of freedom for a diatomic gas. Degree of freedom for a diatomic gas is 5. Right? Taking that into consideration, along the path AB as shown, what is the change in internal energy during this process? That's what the question is, right? So let's try to understand according to first law of thermodynamics, dq equal to du plus dw. At constant volume, as volume is constant, work done equal to pdv. dv is change in volume. As volume is constant, dv equal to 0. So the dw is 0 at constant volume. So in that case, dq can be written like du plus dw equal to 0. So the entire heat supplied is used only to increase the internal energy. Basing on that, we can say constant volume, specific heat of a gas at constant volume is amount of heat energy required to raise unit mole of the gas by 1 degree centigrade. But when you say volume is constant, in the place of dq, I can write du itself. That means Cv equal to 1 by n du by dt. That implies du equal to n into Cv by dt. So now you might understand why I am making this discussion. As you want change in internal energy, I have derived a formula for change in internal energy. Change in internal energy. For a diatomic gas, Cv equal to 5/2 times of R. I have missed something, that gamma for the diatomic gas is actually 7/5. Its Cv is 5/2 times of R. Its Cp is 7/2 times of R. Therefore, gamma is Cp by Cv, that is 7/5, not 5/3, it is 7/5. I missed that earlier. Well, I got Cv as 5/2 times of R. I explained to you in the other video that how do you get this value. Please go through the playlist to know the values of that, why it is 5/2 or something like that. Now, once you know this is Cv, I can write further du, change in internal energy, as n. Cv means 5/2 by R. dt means T2 minus T1, change in temperature. But change in temperature is not given for you in the problem. Rather, values of pressure and volume are given for you. So I shall convert this change in temperature in terms of pressures using the ideal gas equation. What is that? PV equal to nRT. So I can write P1 V1 equal to, for a given gas at a given temperature, nR T1. That implies T1 equal to P1 V1 by nR. And similarly, T2 equal to P2 V2 by nR. That implies this du value can be written as n 5/2 times of R. In the place of T2, P2 V2 by nR minus the place of T1, P1 V1 by nR. So nR 5/2. Again 1 by nR is common in these terms. P2 V2 minus P1 V1, nR and R gets cancels. So the value of change in internal energy du can be written like 5/2 P2 V2 minus P1 V1. where the values of P1, P2s and V1, V2s are given for you in the problem. Let us just substitute the data and see what is the answer is. Apply change in energy is 5 by 2. P2 means this place. That is the pressure. 2 kilopascal, that is 2 into 10 power 3. V2 means 6 meter cube. Minus P1 means this. Corresponding P1 is 5. Kilo means 10 power 3. V1 is this value. 4 meter cube. So this is 5 by 2. 2 into 6. 12. 5 into 4. 20. 10 power 3 is common. 5 by 2. 12 minus 20 means 8. So this is 4 times into 10 power 3 is there. 4 into 5 is 20, of course. Being 12 minus 20, it's minus 8. So minus 20 into 10 power 3. 10 power 3 can be written as kilojoules. So the answer is minus 20 kilojoules. So solving this problem is quite simple. Just a formula based concept. We only need to know the formula. So I'm emphasizing a lot on graphs simply because of late we see a lot of questions are asked on graphs of thermodynamics. So familiarizing yourself with the graphs and solving the respective problems is important for you. So the only thing you need to know is gamma of a diatomic gas. Cv is 5 by 2 times of R. Cp is 7 by 2 times R. Therefore, gamma is ratio of Cp by Cv, that is 7 by 5. Further, I have written very definition of du. It is already known for you, just I have derived for it. I have substituted. I have just converted temperatures into pressures because the data is given in terms of pressures and volumes. That's how we solve the problem. Thank you for watching.